And yet another example for Gauss-Jordan. So I'm just going to go right through and write the augmented matrix. So we have 1, negative 3, 6, and we have negative 3, 9, negative 18. So again, we have that 1 in the upper left-hand corner. So this is good news. No fancy footwork needed here. So again, I'm just going to call this R1, and I'm going to call this R2. And I know that I need to get the 0 here. So the way to get that, again, thinking about the elimination, I need to take 3 times the first row and add the second row. And what that's going to give me is a new one to write in the second row. So 3 times the first row is 3, negative 9, 18, right? And the second row is going to give me negative 3, 9, negative 18, and wow, a lot of stuff happens here. If we add those together, we get all zeros. So that means my new matrix is 1, negative 3, 6, and 0, 0, 0. So, wow, we have only really one workable equation here. So let's think about this. We have x minus 3y equals 6, and we have 0 equals 0. So 0 equals 0 isn't really telling me anything I don't know. So I'm going to kind of ignore that. But what this means is, since we only have one equation with 2 variables, I really have a situation where there is infinite solutions. And if you want a graphical perspective of that, that means that any point that falls on the line x minus 3y equals 6 is a solution to this system. So one thing we're going to learn in this course is how to express that using symbols. So what I'm going to do is I'm going to solve this for x. So I'm going to say x equals 6 plus 3y. So what that means is the solution set is any point xy. Well, maybe I don't want to write it that way. So the solution set is x comma y, which turns into 6 plus 3y comma y. And why is that more advantageous to write it that way? It's because I only need to know one variable to get the solutions. So what that means is, if I want y to be 0, I know that 6 comma 0 is a solution. If I want y to be 1, I know that 9 comma 1 is a solution. If I want y to be 2, I know that 12 comma 2 is a solution, and so on and so on. So this is just a more convenient way to express the solution set to a system of equations where there's infinite solutions.